Fine. So students, here we will discuss the good questions. The first one we will discuss about the short trick. Remember, the accurate answer always comes from calculus, but you can use the short trick for faster calculations. What this question says, a body cools from, let us say we are having a particular body, because if I will write the question it will take more time. So it's better I dictate. A body cools from 60 degrees centigrade, initially 60 degrees centigrade to 50 degree centigrade, and the time it takes is 10 minutes. Now find what the question is saying, find its temperature at the end of next 10 minutes. Means it the body has cooled down from 60 degrees centigrade to 50 degrees centigrade in 10 minutes. So in the next 10 minutes, what will be the final temperature of the body? This particular thing we have to calculate, and it is given that if the room temperature is 25 degrees centigrade, it means that surrounding is having temperature of 25 degrees centigrade, and it is also written that Newton's law of cooling holds. Okay, when we say that Newton's law of cooling holds, when the temperature difference between the body and surrounding is not very high, the difference part is low. However, it is mentioned in the question. If suppose it is not mentioned in the question, then by observing you can see. Otherwise, we will apply the Stephen-Boltzmann law. And one more thing I need to mention, this Newton's law of cooling can also be derived from Stephen-Boltzmann law. However, Newton made this law based on his observations, but it can also be proved from Stephen-Boltzmann law. Now, in the case of Newton's law of cooling and applying the short trick, see, minus dt by dt is equals to k T minus T naught. What I can write here? Minus dt. 50 minus 60 minus 10. Let us keep it in degree centigrade also, because here degree centigrade here also we can cancel out. So we don't need to convert it into Kelvin. Divided by, this is 10 minutes, K. This one will be average temperature. 60 plus 50, 110, divided by 2, 55. So my dear students, this will be 55 degree minus T naught. What is the T naught? T naught is the 25 degree centigrade. Is this part clear? Now what they are asking, what will be its temperature again after 10 minutes? So let us say this temperature be T. Now minus, this will be T minus 50 degree to be divided by dt. 10 minutes is equals to K. Here again what we have to put? Average. T plus 50 divided by 2. So T plus 50 divided by 2 minus the temperature of surrounding. 2b. No, there is not something divided by 5. So it is K and this. After that, this is equation 1. This is equation 2. Now what you can do? Divide these two equations. K to K will part will get cancelled out. After the division of these two equations, only one variable T will remain, and that mathematical part you can do and you can find out. Is this clear? If you are not able to find out, then after the class or in the next session you can ask. But I can believe that your problem solving, your mathematical equation solving skills to be very good. So, and I have given you the hint how you will solve this part. Now we will move to the next important question that I will explain each and every part, and you have to remember that particular result also. Now, hmm, see, this important question is also discussed in HC Verma, okay, in some solved examples, and here also it is discussed, and it is one of the good questions based on Newton's law of cooling. Now, what this question says, a hot body placed in the air is cooled down according to Newton's law of cooling. It has been already mentioned. The rate of decrease of temperature being k times the temperature difference between the surrounding starting from t equal to 0. Find the time in which body will lose half the maximum heat that it can lose. Is this clear? Let me explain you the question. Suppose you are having a body for which temperature part and something is not given. Let us say temperature initial and the temperature of the surrounding is T naught. Here Newton's law of cooling is applicable. That means that difference is not very high. Now what you have to do, see, question is asking find the time in which it will lose half of the maximum heat that it can lose. Okay, so let us say it is having the specific heat capacity as so the maximum heat that it can lose, maximum heat that it can lose will be how much? Mass, let us say its mass is m into specific heat capacity into delta T. That okay, it will lose its heat unless both the body and surrounding has the same temperature. Okay, so m into s Ti minus T naught. This is the maximum heat. You can say that delta Q max that this body can lose. Now it is saying to find out the time in which it will lose half of this maximum heat. So now what we will find, after losing half of this maximum heat, what will be the temperature of this particular body. So at delta Q max, let temperature of body be T. Fine. Now, so let us say that to be delta Q dash m into s into T minus temperature initial. Is this fine? T is wait, here it will be temperature initial minus the present temperature. This is the half, this is half of this maximum heat lost. So you will write m into s into Ti minus T naught half should be equal to this particular heat loss, which is m into s into Ti minus T. Fine. The present temperature is T, so Ti minus T. Ms, Ms. These two will get cancelled out. From here is equals to 2 minus 2T. Now From here, my dear students, you can make calculations. This shifted here, this. So 2t minus t. T will be remaining. This temperature initial. This will shift here plus T naught to be divided by 2. I hope this mathematical part is clear to you. This shifted here, this fine. Now, it means when the body loses half of maximum heat that it can lose, the temperature of the body will be temperature initial plus temperature of the surrounding divided by 2. Now, which formula gives us the relation between temperature and time? We have got important formula from Newton's law of cooling. So, what you have ln, or you see that minus dt by dt is equals to k t minus t naught. So, you will be getting this thing ln t minus t naught, and this was the zero time. At that time it was temperature initial, present it is t, it is the time now t. So you will have ln t minus t naught upon ti minus t naught is equals to minus k t. This particular thing you will have. Now,